So I was just messing around. I'm going to wait and see if anybody wants to show up and hear what I got to say and what I have to show people data wise. Maybe they can tell me that it's not what I think it is. And I'm pretty shocked by it. Something that I didn't believe could happen, especially not with what I'm working with. All right. Well, I'm just going to chillax for a little bit. With this crowd. Yep. See if anybody wants to show up. And I think that this is just spectacular. Wow. 2 minutes in. Everybody's out partying. Oh, here we go. Hey, what's up? Oh, I think I've discovered something pretty amazing here. Just with what I'm working with. We got like a 1/4 watt or less going in. And one thing for sure, we got more amps coming out than we do going in. And more volts. So I guess, what do you call that? What do you call that when there's more coming out than there is going in? We got 0.1, we got 160 milliamps coming out. We got less than 100 going in. Up to 100 going in. So, it shows 0.1, and most of the time it shows 0. So it's like in between 0 and 0.1 amp. This right now we have 0.77 of a volt going in and 100 milliamps. That's some pretty good kinetic motion there for just less than a volt and probably less than 100 milliamps actually. So we're generating 32 volts, 33 volts, and 0.16 amps. So it's like 12 watts. We got a 1/4 watt going in or less. Thank you, sir. I'll take care of that. So there is a difference though. This is DC going in and AC coming out. So I don't know if that's a huge, like the calculation of the difference between the two, but I'd say it's more's coming out. Obviously. Let's check the amps one more time. Well, that's DC amps. So we got 100 milliamps of AC coming out. A tenth of an amp can kill me. I don't know. I mean, in the right circumstances, I could say that's true. I've been shocked with this thing several times, so I don't know if that's 100%.
But thanks for saying that we got something.
I appreciate that.
He's been shocked a few times. You should check out the video overall.
So this is 12,000 turns of 32 gauge. And I think what's making it so powerful is the shape of the coil. The actual shape of the bobbin keeps all the copper in the magnetic field of the permanent magnet. It's like it's completely saturated. There's no part of this coil that is not being hit by the most intense part of the field. And the generator coil's got the same shape as the drive coils, so it's virtually the same thing. The thickness is what I'm talking about.
Oh, he does work for the power company.
Oh, I believe you. I believe you.
Yeah.
I told 100%. If you can drown in less than an inch of water, you can die from a tenth of an amp. But I still believe in the circumstantial thing. I don't know. Maybe it's just voltage that was shocking me. That could be totally true. Oh man, this is all right. So right now we're drawing 0 or less than 100 milliamps. I never say like flat 0 because that's bullshit. You got to have some kind of current. So it's less than 100 milliamps. And here we got more than 100 coming out of AC. But then, you know, only if the values are equally weighed, then it would be more coming out than it is going in.
Werder, do you know the or Werder, do you know the calculation from AC to DC?
Like amp wise, we go DC, we got 1.6.
Okay.
And we go AC, we got 100.
So 160 milliamps versus 100.
Yep. So I don't know. That's huge though with what I'm doing here. The 60 milliamps is huge. So that might be it right there. But I don't know. I'm still really excited about this. This is great. When I get this thing spinning like that at under a volt and less than 100 milliamps, I'm happy with that.
That is included to the plug.
But as for like watts, there are I'm not sure if it was this configuration, but we figured out that it was like 4,800% of an increase in what came out than what went in.
So that was AC. So AC was 100 milliamps. 0.1 times 33 would be 3.3. Something wrong. Does that sound right?
I don't remember. I don't know what you just did. I don't know.
Calculated watts
Oh yeah.
on the AC.
Yeah, you said 3.3?
Yeah.
Okay. That's awesome. So a quarter watt in, 3.3 watts out. And you know, honestly, I think it's because there's more magnets on the rotor.
What up, Kyle?
Hey, what's up? How's it going? I thought we had over unity here for a second, just with this thing right here.
Thank you, Berger.
Thank you very much. Yeah, I do appreciate your concern. That can send. I'm pretty sure it's the old ticker. I will be careful.
Anybody has any questions about the build or the setup? Or the circuit or the power going into it? So drop a like, subscribe if you haven't yet.
Can I get some help?
What?
Washing machine. Trying to get it on.
You gotta be joking. Is the soap in there already?
Yeah.
Yeah? Just hit that. Is it closed? Just wait. Should work. Just wait.
Like 50 tries.
Why didn't you just wait?
I waited. Like 5 years. I'm pretty sure everybody heard that. We were struggling with the washing machine. And I had this microphone on. So
I didn't even hear that. Okay.
yeah, you didn't hear it.
Got enough power to run a stereo. Nice.
Awesome. Awesome. So this drive coil and this drive coil, 9 magnet rotor. So you got on, you got off, and so something's on all the time with this. You got
a 4-filer coil of 26 gauge. So these are all 4 strands are 26 gauge, and they're all hooked up parallel to their own transistor on both sides. So they're equal 215 turns for every strand. So it's real short. It's real powerful burst. I don't know if it'll handle a load though. I'm not sure. I don't remember. This is actually the first time I've had both sides of this thing together at the same time with the same coils.
So double O.
Hey man, how's it going? And then we got the external trigger coils, which allow the timing to be changed if necessary of the drive circuit. And then this little beast right here, I'm telling you, man, it's generating more. It appears to be generating more than I'm putting in.
Happy birthday, my man.
Happy birthday, Double O. Heck yeah, 39. That's a good number.
Yeah. There we go. Let me see that one.
And now that we got that, I want to check something. We're going to do auto sine wave for this much power.
Oh yeah, that's like a nice calm day at the beach.
With like 104 spike peak. That's 104 volts. Oh wow, dude. This thing really shines when you turn down the power. When you turn it down to like below a volt, this thing just blows up.
What are the hertz? Let's see.
Oh, you still got a year to go, bro. Before you hit that hill, the top.
17 and 18 hertz.
Yeah. Yeah, that sounds about right. So that's not that's not even like a, yeah, there's where the differential is. Because with the power that's coming out of the walls, the 60 hertz power, and to get at least, you got to have at least equivalent of 60 hertz to even compare the two, really. Good. Heck yeah, man.
Me too. Oh yeah. Yeah. Straight up, yeah. I'm a newbie here, but yes.
All right, here. I want to try something. This is what my first test was. It was at 150. And I love having this power supply because I can do like minute changes.
Yeah, we're gonna run the boom box.
Yes, the hertz for this motor increases as the speed increases. I'm pretty sure for every motor.
You turn it up just a bit.
Yeah, I just turned it up to 1.5 volts. We're now drawing 200 milliamps.
That's 60 volts.
Are you talking about my generator coil, Double O?
Yeah, I got that. I got that emoji. Yeah.
What do you want to know about it? Does the hertz increase? Yeah, that's the one we're monitoring at the moment, the pickup coil. Yeah, the hertz have been increasing. 33.3. Oh. Oh.
That was a nice hit.
Yeah, the rotor definitely, I've turned it up times 2 right now. We're at 1.5 volts and 0.2 amps. And this is almost double the speed it was just a second ago.
Yeah, this is about double what it was.
Now, just to prove that, we'll start right now. All right, we're at 236. Is that what it is?
Yeah.
Okay. Now we're going to turn it up to 2 volts, or you want to go straight to 2.5? Look at those amps just go up as that's crazy. 2.5. I'm just going to leave it right there. That's good enough. We're up to 44, 45 hertz. As soon as we get to 60 hertz, we'll check it. We'll see what we're doing. .52 hertz, 53 hertz. I think we're going to get to 60 hertz at 2.5 volts. .60 hertz. Okay. Let's now look at the voltage. It's going to continue to go up, but that's okay. It's bare minimum right here. .117, 118, and then I can see I've had trouble running anything but lights. You're covering the yeah. I've been having trouble running anything but lights with this pulse motor. But you said if I can get it up to 55 hertz with 110 volts and 3 amps. Oh, that's awesome. Now, does it have to be constant minimum, or does it have to be constant like that, or it just can't drop below a certain point ever?
Okay, so yeah, you're making some tea, some coffee,
Yeah.
hot shot in the
Well, I mean, it can though. I mean, it's just it can't slow down below a certain point. Yeah, it's got to maintain a minimum amount that'll allow the load to run.
Excellent. 007. Excellent.
Tea in the woods.
I'm jealous just thinking about it.
Oh man, if I had tea in the woods. Oh, this is awesome. All right. But see, now it's equal, except for the voltage. Because over here, we got 2.66 volts in, but we have 600 milliamps going in. And over here, we got 600 milliamps coming out of the DC variation. Yeah, it's not a DC. Well, it's reading a DC off of this coil, and I'm not using a rectifier. But 0.4.
D. Thank you for putting that in where it's got. That's
Yeah. All right, so this is definitely not the direction. But I bet it's unity. That's what we have here. Because of how little we're putting in. We're reaching a unity state.
even just switching it changed the tone it was making.
Yeah, one of these settings has a load. So 120 volts, which is awesome. And it's 2 volts over there, 2.5 over on the power side. So I can't do the math in my head right now. But we'd have to level out the amps. Oh, it says 0.5 now. No, 0.6. Okay.
There it goes.
All right. So the faster it goes, the more amps will drop off. But like if I had to just guess, I'd say they're equal. When you do 0.4 amps times 120, and then you do 0.6, no, there's got to be way more coming out, man. My logic says this can't happen, but it's happening. It's happening right now. And what I really thought we had something was when the amps were higher. That's a frequency.
Okay, I see. That's that.
Yeah. I wish there was a way for me to like, because there's a setting on here that just is a load. This one right here. Capacitance. Wow. Resistance. All right. What's the problem? But let me check that real quick. There's a setting on this that's a load for the rotor. Oh, this one doesn't do ohms. I have to hook up my other multimeter real quick. Am I going to get a good ohm reading with it moving like that? Ohms is resistance though, right?
Yeah, that's an ohm sign. There we go.
All right.
So around 150.
Yeah. In theory, I would assume that would work. But the loss in this thing is tremendous. I've tried doing multiple different kinds of loops. I've done coil to itself. I've done coil to master power distribution. I've done like hooking it right here and having it feed into everything. But it never runs itself for very long. Yeah, I've used diodes. I've used like 5 different kinds of diodes. I've used rectifiers. I've used Zeners. I've used flyback specific diodes. I've used diodes. But if you want to walk me through the process, maybe I hooked it up wrong. I mean, seriously, that could totally be a thing. So let me read what you wrote here. So run it through a capacitor first. An AC capacitor? Like, could this capacitor work? So what coil are you talking about wrapping back into the power supply? This one? Or back into the power feed? And I'm telling you, you're not talking about putting it in here, right? Yeah. Okay. So the generator coil, the coil that is designed specifically to generate electricity. I gotcha. So do we need to ground this coil? Nice. Oh yeah, I wanted to show you guys on the stream here. With the dimensions of my magnets, this is a former for a coil for a Newman motor. No, 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 no. The positive end or the negative end. The ground. You talking about putting it in the ground, or you talking about putting it in the positive of the power supply? Because you said into the load of the power supply. I don't know what that means. All right, so let's look at it real quick. You're talking about these right here. All right, so you're talking about putting a cap right there and having it tricking. I get what you're saying, dude. Oh man. But see, look, man, I have two. I have two. So I mean, couldn't I utilize both of these in that same sequence? Or okay, but definitely I wonder how I could even utilize that. Because my ends are so short. They're so short. There's nothing left to like clip anything to. Okay. All right. But do I need I need the cap, right? I need this cap. It is a start cap, AC. All right. Hold on just a second here. So I'm running a double connection basically. I'm going to leave these plugged in, and then I'm going to attach this just virtually on top of that. And it's going to be feeding the live wire, the little L right there. Sweet. I don't know if I can, if I have what it takes. I don't have any solder or anything, so I don't know if I can do that. Let me see if I can clip it up. Here we go. I think I got it on first try. Ah, very good. Yeah, I could do that. But then I would need to run a switch of some kind. No, I just turn it off. Oh, we'll see. Let me do it. Huh. I'll take this with me over here. All right, so we're going to need to ground this beast. Hey, bro, I'm going to need both my hands. My man. Thank you, sir. No. Man, I'm going to break your phone upside your head, dude. All right, so I got one in the N and one in the L. I hope that's right. If not, I'll hook it up over here, but I don't have an open slot for it. So I'll have to attach the breadboard to the power distribution. All right, let's turn it on. See if we can't get that other thing going. Oh, hell yeah. It works. Kinda. All right, it's got quite a load though. So let's turn this up to like 5. Oh yeah, we need the haha. That's what the problem is. And the capacitor. All right, now I just need, this will work. It's a little long, but it'll work. I've now used like all of my uh, alligator clips. Now I got left is crocodile clips. All right, let's see if that helps. And we're just trying to get that running smoothly. Look at that. Why isn't this, yeah, like I said, it's like it won't hold the load. There it goes. No. All right. So,
Not sure the cap is available.
well, I mean, it's not going to work either way because it's not designed to hold a load, but we'll give it a shot. Because I just tried it without it. But maybe I didn't give it enough time. And we'll just clip it instead of screwing it in. Looked like it was running pretty smooth. Now let's turn it on and see. Wow, dude, that works. That's awesome.
Good work, guys.
Thank you. Thank
Good
you.
work, guys.
Now let's see if we can do this without using this one. Just using that one. Ah, yeah, it's working. It's functioning. I just had like 12 volts running through it. That's awesome. Thanks, Peter. You got this, man. You hooked it up. You hooked it up big.
Right?
So we're going to bring this here around like this. Oh yeah, we need a diode.
Likewise, Carol.
Which way does the diode go? Do I got to flip it around? Hey, Mike, how's it going? It's preventing the flyback from the wall. Oh, I know that. It's just like, I know. Just which way do I turn it? This way or this way?
So does one way mean line to negative, one way mean line to positive?
No. This gray line right here is positive.
Got it.
Yeah.
I got it. I'm learning here too. Cameraman's learning.
Actually, I think it's the negative.
Stripe faces positive terminal.
Positive terminal. Stripe faces. Okay, stripe faces positive. Here we go. So we're putting this on the butt end. Somehow that doesn't seem right. Okay, so flip it around. And this is going to prevent. Well, no, if I. Oh man, see if I had a soldering gun, this would probably be easy. All right, so we're gonna go from the power supply. No, we're gonna. Which way should we work this?
There it is.
We send the power out of the battery. So this coil right here is going to be our battery, and we're
All right, man, I got about
Okay.
5. I can put it on the tripod.
Put it on the tripod in 5 minutes. All right. See, I think this diode is going to just totally screw this whole thing up. I don't even know. Because we're preventing flyback, but are we preventing? Because I don't, it seems like there's a breakdown here. We were taking the electricity from the coil and we're putting it back into the power supply here. But at the same time, we have power coming from the wall and we're trying to keep those two separate. But I don't want this power going into my coil. I just want the coil power. So this has got to be the other way around. There we go. Solved. Bingo. Because our battery currently is a coil. All right. All right. I just want you to see this work, bro. That's what I want to. I want you to see this work. Where's my screwdriver? Oh my lord! There it is. All right. So, and then we're gonna hook this to the end of the power supply because our distribution board is completely full on the negative side. Well, what just happened? I hope I didn't blow a transistor doing that. Yeah, there's something going through the coil. Yeah, the guy said we're gonna fry the coil. I think he was right. All right. So maybe I need another diode. Could that be right? For the negative side? Because it seems as though when I hook up the negative side, the coil is permanently a magnet at that point. So here, let's try that. Oh, that might be it. Heck yeah, good job, bro. All right, here we go. Gonna let it juice up a little bit. Power's cut. I think this is working. I mean, what should I do at this point? Should I unplug it from the wall after we juice it up? Yep, that's what I'm gonna do. Because I know that turning it down doesn't really work that well. I have no idea what that means. Leave the negative wire hooked up to the power supply. Huh. Yeah, this is not on right now. So, man, that isn't gonna work. So we do have to have it grounded. But the thing about having it grounded is that coil now becomes a magnet. All right, so we're gonna try this one more time this way. I'm gonna plug it in. And we're gonna spin it up. Ah, none of that, it doesn't make any sense to me. I don't know what that is. Tell me exactly like what it is that I'm attaching to the earth. Or I mean, I'm in my bedroom, so that doesn't make any sense to me. I'm literally like 3.5 feet off the ground. I think I need a diode here. And that's all right. I just don't know what you're talking about. It's all good. Uh, all right, let's see. I think we're good. I think we're good. I got an even better idea since this isn't, I don't feel like this is going to work the way I want it to. I'm going to use, probably should have done this from the start. This second one. And we're just going to juice it up and then we're going to run it. Because I actually got to turn it on. And it had input data on the screen up here. So the voltage on this thing is continuously dropping. So I'm assuming that it's eventually going to stop. If it doesn't, yeah, I don't know. I'm not really interested in the one guy that did it. You know, here, man, it looks like the voltage is just trying to climb up now. So maybe we were breaking even as it gets slower. And I don't think I need well, Maybe I do. Maybe I do. Maybe hooking it up that way is just going to break it. And I don't want to break it, so. But let me show you progress. All right, now let's turn this back on and see if we can't get it lit up real quick. Real quick. And see, now all the diodes are not good. All right. So we got it turned on. This alternate power supply turned on, and I can turn up the voltage. Okay, it works. I can use that. That is awesome. Now, what I think I might be able should do is hook up one of these units. All right, let's see how long for that will remain on with me turning it up to, like, say 6.5 volts. That's awesome. That's awesome. See, now I can do it. Now, if that's legit and that's actual voltage coming out of that thing and not just a digital display, I can set up another rotor. I can start really getting down to business. And then it slows down. I'd say that's our best bet. All right, so I love it, man. I like it. It can handle the load, and I'm happy about that. That's going to pick up pace on its own. Pretty sure it's already got 0.1, 0.2. Wow, I don't even know. All I know is that when I thought I had over unity with this, I was like, I gotta do a live stream real quick and see if this is even real, because I don't think it's real. But we had like 100 milliamps going in, less than a volt and 100 milliamps going in. We had 33 volts and 160 milliamps coming out. That's great. Phenomenous, man. Phenomenous. And I'm pretty sure, heck yeah. Yeah, man. When I saw that we were creating more amps than I was putting in, I was a little skeptical. And I think I was right to be skeptical because, well, the second one here, and I can turn it on, man. I can turn it on. That's so cool.
Wow.
And I figured it in my head. I'm like, we drop the voltage and everything. We low input and see what we can get out of it. And this is just a perfect setup to do low input and get lots of kinetic energy out of it. I do. I mean, when it boils down to it, it is about one guy, typically. And that's how it's been from like people started inventing stuff till now. It's always the notoriety is always given to one guy, and that's bullshit. I'm telling you right now, he didn't do it by himself.
Love your passion.
No, I'm talking about unity and over unity. I think you're right, 007, but that's not the point that I'm arguing or discussing even. I'm sorry, man. I didn't get any sleep last night, so I'm a little choppy around the edges right now. The way it's been described to me and from several different people. Dude, I've been about being awake for long periods of fucking time, man. You would never believe because you're all trapped in this little bubble about 7 days and you're gonna die. That's bullshit. That is utter nonsense. Okay, I've been awake for a lot longer than 7 days at a time. Oh, yeah, I would imagine it's pretty late there.
4 a.m. So you gotta be out in Europe.
Yeah. I've been up for 28 days in a row one time, and several days, like 10-day stretches I've done. I mean, 28 days in a row. I was all jacked up on Ritalin, and I had 90 pills, and I just took one every 3 hours till the bottle was gone. But that was bad. And I'll never, you make mistakes in your life. That's one thing I'll never do again.
I was there. All right. Good work.
All right, my bad.
Have a good night, everybody. All right, I'll see you tomorrow.
All right, man. Sorry to hear that, Cal. Just smoke weed. That's all I do. Smoke weed. And then the Ritalin, man. I was so addicted to that back in the day. They thought I was ADD later, and they were wrong. I'm bipolar. So I got the drugs that made my illness worse. Yeah, anxiety sucks, man. Yes. Yes, sir, Mike. And PTSD sucks too. I think I have quite a few symptoms of that. Not from anything in particular other than my own stressful life. Yeah, that's awesome, man. As, as long as that's what you like to do. Yeah, I could do that. The magnesium I know is really good for, I guess, breaking stuff down. What was the other thing for? I mean, my brother does that stuff too. The organic. Uh, yeah. Hmm. So that's going about 800, almost 900 RPMs. Mm. All right, I'm gonna step back here real quick. I want to show you guys my magnets for my Newman motor design. I think we went over this before. Man, Get that magnet. So I'm gonna wrap. I got a question about the Newman motor coil. Is one strand good enough, or should I go like 2 strands? Because I'm gonna get 5 pound 5 pound spools of 18 gauge. See this magnet? I gotta show you this thing, man. It is 1.35 by 1.35 by 2.35, and the north and south sides are on the long side right here. So it's not like this, and it won't spin like this, but it'll spin like this. Yeah, but I don't have a soldering gun. So with that in perspective, can I still do it? Okay. I could probably use like one of these things. But I can do it with one strand, right? I don't have to have multiple strands. Yeah, wire connector. That's what it is. Because, 5 pounds of copper cost 130 bucks basically. And I need to make 2 of these. Okay, cool, man. Especially with 18 gauge, right? Which invention? Yeah, I'm not a bargain shopper, Mike. Really? You serious? Mike, are you serious, man? Oh, that's 28 gauge though. I need 18 gauge. I've got 4 pounds of 26 gauge, and I've got 4 pounds of 24 gauge. How'd you get all that copper, Double O? Oh, you've had it. All right. But how'd you get it then? Did you just, it was just like from an auction or something? Oh, okay. That's neat. That's neat. But yeah, I need to find like this is altogether about 10 pounds of copper, 18 gauge. Um, and then I'll make I got another one of these magnets coming, so we'll get an axle and we're gonna put them together, and then it's just the right amount of size here to spin. Mm. Thank you, Build. I appreciate that. I built it all from scratch except for the tables, the plastic tables. And before I even got started, it was like it narrowed me down to a 1/4 inch shaft because the pegboard is a 1/4 inch. What about now? You check anytime soon, Double O? Okay. Yeah, I have to make an eBay account. You know, I don't think I have an eBay account. And then yeah, I keep on having these visions of like never barely any motion at all moving past like copper or a coil of some kind, and it sounds like it's scraping, but it's brushless, and it generates a lot of power. Yeah, I should probably definitely look into doing that. But that, yeah, man, I was thinking about it. The more and more we were talking about it, and yeah, it seems like it might be worth my while, especially with the magnet like that. 2 magnets like that. Thing's going to be generating just a lot of power, even with 1 strand. Huh. Oh man. And I had like 2 drive pickup coils right here. One for this trigger coil and one for this trigger coil. Or just basically one for each side, basically. So each coil now had 2 drive coils on it. And I don't know, everything was in series, and I had to jack it up to like 40 volts, but it was pretty smooth, and I mean, like it worked pretty good. Yeah, there's my shaft. Here we go. This will be the shaft for this thing. Now I could do some pillow block bearings. Or I could just, file out some little slits. They just got to be equal. And it's weird, man. I eyeball all this stuff, man. I mean, you get a good measurement and stuff, but I didn't measure the magnet, and this is what I came up with, and then I put it in there. I'm like, and two of them need to be able to fit in there, and voila, man, it's like perfect size. Is that like a handle, Mike? A wrench? Oh, you mean the total power input for the motor is under 10 milliamps? Okay. Let me see, because I'm not. Oh, right. Let me, because it's not on my computer. Let me get it up here. All right, Mike. All right, Mike. All right, Mike. Haha. All right, Mike. Oh yeah, man. Post it up, man. Post all the good ones. It's amazing how centered that toroid is when you think about it. Still off center, but it's pretty close. Yeah, yeah. I got a little bit of it. It's like 65 feet of it right here. Oh, wow. Then maybe I shouldn't do 1 millimeter wire if I'm only going to use 10 pounds of it. Because those ohms are not the way, the numbers I see and the ohms I need to have are, that's an insane amount of copper at 18 gauge. Yeah. Yeah. This coil right here is 424 ohms. Yeah. So maybe I should go, instead of 18, maybe a 20 gauge. Yeah. But I can kind of do this in my head, like take this and unwrap it and then wrap it onto that one just by holding them together. And I'm still, I gotta have thicker wire than that. That's 32 gauge. So 28 actually, or 26. 26 has been my horse since Peter turned me on to 26 when I was working in the other room. This is 26 running this thing right now. It's like worked the best for me. Yeah, 32 definitely has a lot of ohms. Oh. Mm. Well, I've already got all that stuff sorted out. It's a pretty nice size magnet. And it'll fit in here just right. Two of them actually, a north and a south sided thing. Yep. You know, it all depends on what you're trying to do. I mean, for the most part, once I get this all together, I'm not going to really be seeing what's happening on the inside unless I look down on it. It's all about what comes out of it. And then, you know, that's really not any fun, actually. This is way more fun. This is why I did this first. Mm. And now I understand exactly why all this circuitry could come into play, because the power supply typically in a circuit isn't connected to the wall. It's a battery. In most circuits in electronic, it's usually a battery. And when you hook up a battery, you got way more options because you're not tethered to the wall. Yeah, each one of these 9 magnets in this rotor are 40 millimeters by 20 millimeters round. And there's 9 of them, and altogether they weigh about like 2 pounds or something like that. Yeah, I can click on his links. Yeah, I got him. What's going on? Oh man. I got it on my phone, I got it on my computer, and I got it on the TV right now. So here we go. There you go, my man. It's amazing that I'm drawing so many amps at such a low voltage. I'm using MPNs. Kind of weird. Yeah, I've seen his stuff, dude. His latest one about the maglev. Dude, I'm going to show you something that I've been using for a year and a half, man. So this basically just sits down on the ground flat, right? And it was basically made for this other colorful piece, this rotor right here. And basically it would maglev it, but it's like pushed to the outside, and it's exactly but yeah, the maglev motor that he just made, or video that he just made, dude, I've been doing that for years. Not just the maglev for most people just is focused around the shaft, and I get that. But for me, you push it all the way to the outside, and it'll run. That rotor I've had run for more than an hour. Yeah, lid motor. He I'm just shocked that he didn't know that already. That was going to work like that. It seems like he would have known that. Hell no, man. Man, oh, dude. Let me see. Do I have one in here? No, they're not here. I got these really nice 8-inch maglevs. And, well, I mean, I'm doing this experiment with the 6-inch. And I have these iron rods stuck in a hexagonal shape with toroids centered directly. The poles are directly in the center of the toroids, and then there's a pole in the center, and I plop my maglev disc down, and there's at least 2 inches on any side of that maglev disc that there's just nothing, and the toroids are lifting it up. And then, I mean, it can only get better from there. See, currently it's a mini Newman motor, which I will get 100 or 370 ohms just because it sounds right. And then the magnets I have, one will fit on each side here, and this is perfect size. And then if I want to add like another magnet on each side, then I'll have to make this bigger. Okay, so I don't need more magnets. What does that mean? There's only 2 coils, one on the bottom and one on the top. I'm going to go to bed really soon. My phone's about to die. So when this cuts off, have a good night, everybody. Hell yeah. I'm, I'm so ready. I'm almost half asleep right now. I didn't get any sleep last night. So I've seen the basic Newman motor built out of microwave transformer coils and just a like this, and a magnet. So what do you think the max speed is going to be? You think I'm going to breach 2,000 RPMs with this baby or what? I have no expectations really of what's going to happen. I just figured I'd give it a shot. All right, well, think so? Heck yeah. Are you talking like a PNP or an NPN? Or does it matter which one? All right, guys. Thanks for dropping in. I really appreciate it. I'll take a look at those links. But I'm going to hit the sack, man. I'm done for the night. Thanks, guys. Yeah, me too. MPNs are my style. All right, see ya.